Now, these questions I'm going to walk through, these examples, are from the second exercise of bookmark 3? 4. Second exercise of bookmark 4. So if you want, you can turn there, okay? How do these questions work, okay? All we're doing is we're thinking back to the very first time we looked at any 3-unit trig topic, right? The first one was trig expansions. If you remember, we used it because we needed it for the first principles proof of the derivative of sine. Anyway, so we learnt these guys, right? Sine A plus B. What's that equal to? Richard Tong, you can tell me.
Oh, it is sine A plus B plus cos B sine A. Wait, cos B.
Yes.
The other way around.
Plus B, right?
So you do know trig expansions after
Yes,
all.
I was asking Daniel.
Kind of. Okay, so this is trig expansions, right? So this is not inverse trig expansions. This is just regular old trig expansions, but have a look at what's different, okay? Instead of A and B, some arbitrary angles, the A and B that we're looking at are in terms of inverse trig, okay? So how are we going to do this, right? If we write out the regular expansion first, okay, which looks like this, okay, but we put sine inverse whatever in place of A and B, that'll show us where we should go for the next step, okay? So let's just rehearse the expansion. Sine, now this is A, right? Cos, and this is B. Sine A cos B plus cos A back to the first angle, sine B, 12 on 13. Okay, now let's have a look at this. We can work with some of this, right? Actually, we can work with all of it, but some of it's easier than others. Have a look at this guy, for instance. Sine of sine inverse, okay? Now, do you remember when we were doing some work with, trying to work out what the graph of this looked like, okay? How good is your memory, right? It's got a restriction on it. It's got a restriction. The restriction comes from the restriction of the inside function, right? So this part is from -1 to 1, right? So the whole lot is from -1 to 1. And it'll look like that in that domain, okay? Now, 4/5, is that within the domain that we're interested in? It is, right? It's between -1 and 1. So therefore, I could just say it's equal to that value, because it's within the domain where this statement is true. So I'm fine. Okay? I'll leave this guy for a second. We'll come back to him. This one as well. This is in the same boat as before. Is it in the domain? Answer? Yes. It's between -1 and 1 still. 12 and 13, right? So this is just going to be equal to, I'm going to write it over here because it's going to compress in a second. Sine of sine inverse of 12 and 13 is just 12 and 13. Okay. Now when you've got these guys which are mixed up, here and here, how do we go about these, right? Now, what I'm going to do is I'm going to show you graphically how I think through it, but eventually once you start to get comfortable with these questions, you will not have to do it graphically, and it's really quite easy to do in your head, okay? Let's have a look at this guy. Sine inverse of 12 on 13. Now, the whole premise of this expansion is that I'm thinking of these as angles, calling this angle A and calling this angle B, right? So angle A and angle B, they exist in triangles, right? Because in this domain, -1 to 1, these angles should be acute, right? So I can draw a right angle triangle with A and with B in it, right? So this is angle B here. Let's do that one first. Let's chuck angle B there, okay? Now, sine inverse of 12 on 13, right? This is my angle B. What ratio does that give me in this triangle? Well, sine is opposite on hypotenuse, right? Opposite on hypotenuse. So if this is B, sorry, this is terribly not to scale, but you get the idea, okay? Opposite on hypotenuse is 12 on 13, okay? Now, because that's nice, easy numbers, right? You can see that the third side is going to be equal to 5. Okay, now what I want is cos B, right? This angle here. And cos is adjacent on hypotenuse, so it's 5 over 13. That's cos of sine inverse 12 over 13. Okay. plus, now I can rehearse the process here, okay? Instead of a 5, 12, 13 triangle, which I got from this ratio, you can probably predict here, without drawing it, what kind of triangle does this come from? What are the three sides going to be equal to? It's a 3, 4, 5 triangle. Okay? Now, in that triangle, this is angle A, right? Where is A? Where's A in that triangle? It's opposite on hypotenuse, right? So 4 is opposite angle A. A is up here. Okay? So I want cos of that angle up there, which is adjacent on hypotenuse. 3 over 5. So there's all my evaluation, right? That was the hard part, okay? Just working out where it's going. Now, like I said, do you need to draw these triangles? Well, when you get these kinds of questions, you know, 90% of them at least, okay, are just going to give you nice Pythagorean numbers, okay? So you won't need to, you can guess, oh, that's a 5, 12, 13. That's an 8, 15, 17, or whatever, okay? You don't really need to put that down. While you're still trying to get the hang of it, I think you probably should draw it, it'll help you. Okay? Right, now, I'm going to combine these two fractions together. Since I'm going to combine, and I want a common denominator in the end, even though I could cancel these 5s, I might as well just keep them, right? Because that'll mean there's 65 here and 65 here. Make sense? So I'm not going to cancel those out. I'm just going to get everything over 65. The first one's 20. The second one's 36. So here's your answer. Okay, now just to mention, you know, you actually can, just like with a single one of these questions here, like if I wanted to work out what that is, I could actually just get my calculator out and I could punch that in. In exactly the same way, if you're patient, you can get your calculator out, you can punch that whole expression in, and your calculators are big enough that they can handle this fraction. Okay? So you can just get that answer out, okay? But I'll say what I said yesterday, which is that a question like this will usually be worth 2 marks, okay? So 2 marks implies you can't just put down a bald answer. That'll just get you 1. You need to demonstrate something of understanding how did you get from there to there? What skills were actually used? And the main one is the expansion, right? So I would say you need to put either this line or this line in if you want to go straight there, okay? At least one of these has to be intermediate, okay? Now naturally, people would prefer to probably put down this line because it's shorter, okay?
Put the line above so you know what you're doing.
Right, I think this is a better option, even though it takes so much longer to write, okay? Number one, it shows a better understanding of, like these are just fractions. Who knows where they came from, really, okay? But secondly, suppose you got these fractions wrong, right? In section 1, and then you finish section 4, you come back, and then you're like, is this right or wrong? You look at these fractions, I don't know. Like, how are you going to tell whether those are right or wrong? You don't know where they came from. So this line, on the other hand, you can actually do some backtracking. You can debug. You can work out if you've got an error from this line much better than this line. Okay, so I think that's a better option, even though it's longer to write.